Okay. Yesterday we were discussing all kinds of remote sensing, but today we will be focusing on PET scan, which means positron emission tomograph. Now, how do we do it? Is that we use a process called annihilation. Annihilation is a particle plus an antiparticle. Whenever a particle gets combined or interacts with its own antiparticle,
So it's
they
emission.
complete. Sorry,
It's emission, right?
a muon, you mean?
Yeah, emission.
Yes, it is muon. Whenever a particle, but muon can be a stable muon as well. But in case it is made up of particle of one kind and antiparticle of another kind, then they will not annihilate. But if a particle gets together with an antiparticle, immediately they convert into two photons. Okay, two photons of equal frequency, equal wavelength, and they are emitted in exact opposite direction. Okay, if two particles and antiparticle, they both were stationary before they get together, then they will produce two um, gamma photons in exact opposite direction. Now, we can find out total energy that has been produced because we can find out how much mass disappeared. That will be mass defect using E equals to mc square. Then we can find out how much photons are produced. Then we can find out how much energy per photon is produced. Then we can find out frequency of that photon, wavelength of photon, and equivalent momentum of that photon. So if we can find out all that thing, how can we use it for a scan? See, this is a patient. I hope you can see the blue line over there. You can see head and shoulder of the patient. He is on a platform. This is a receiver. It can receive photons with a quantum accuracy of time. Okay. Now, one more thing, just one second. What we do is we inject patient. For example, this is patient. We give patient a tracer. It can be depending on what we are investigating, what part of the body we are investigating. It can be given orally to the patient, or it can be injected into the blood vessel, into the bloodstream. So once a tracer, what is a tracer? Tracer is beta plus emitter. With short half-life. Not very short, but reasonable half-life, which has half-life in hours, you can say. The best is if half-life is in hours, or in some cases in days. Okay? Because we want the tracer to get gone from the body as soon as possible. So tracer is injected into the body, which produces what? Beta plus. I hope you understand what beta plus is. Beta plus is a positron that has been emitted. So listen, if a positron is emitted over here, and it can find out a nearby electron, so what will happen when an electron sees a positron? It is love in first sight. They just do one another and they annihilate. So what happens is they will produce two photons which will be emitted in exact opposite direction. Okay. So there will be a photon produced here. There will be a photon produced. Here. So what we can do is we can receive these two photons with a very high accuracy, and by the amount of difference of time, we can pinpoint the position where this photon is being produced. Listen, if this is a patient's head, this is where the photons are produced. One photon went towards left, one photon went towards right. So I hope you can see that this one will get a little sooner than this one. This is for photon A, this is photon B. So the receiver will receive A before B. So time for A will be a little less than time for B. And receiver knows exactly these 2 points, A and B. So see, this is just simple physics. If I know that the point that I'm talking about is on this line, and I can find out the difference of distance, I can pinpoint the position, exact position where that photon was emitted from. Because if I know the line between A and B, and I know the time that particle took to get to position A, and time, I know time to go to B, I can find out the difference of time, and that can allow me to know how much away from the center it is. That's it. That is the simplest thing that I need to know. And I can pinpoint the position. And if computer is given multiple informations of pinpoint positions of different particles or different positions in any organ, it can generate an exact image by calculating those distances and everything. It can find out exact position of each photon, and then it can use that position to make an image of that part. So see, this is how an image is produced. This is not an image that is seen by a camera. It's not a photograph. Computer has calculated different points and their intensities, and then computer has calculated their distances. On the basis of those distances, computer has generated this image. It is a tomograph. Remember, wherever this word tomograph comes in, it means computerized image. It is like in a police station, there is a Sergeant Tom who can draw image of any criminal or any suspect based on information given. Somebody tells him that the person was tall and short, or fat or slim, or he had brown eyes and sharp nose and big lips, and whatever is given to him, he can combine that information and make an image. So this is tomography. So tomography means we can generate image on the basis of information. It is not a captured image like we do in X-rays. Okay, it is not either an image that that we get from endoscopy. I hope you know what endoscopy is. Endoscopy is we send an optical fiber into the human body, send light in, light reflects from the inside of the human body and we capture it on a camera and then produce it on a screen. That is also not a computerized image. But CT scan, CT, computerized tomography. Again, tomography, it is a kind of image that is generated. Even MRI is a generated image. CT scan is a generated image. X-ray is a direct image. This. Okay, so this is whole body PET and CT scan done together. Okay. So this is actually every scan has different kind of information. Okay. So this was all about PET scan that you need to know. Now, what are X-rays? How X-rays are produced? A fast moving electron is decelerated by a metal target all energy, all kinetic energy that is lost by electron is released as a single photon. If deceleration is by photon produced belongs in X-ray part of electromagnetic spectrum. So to produce X-rays, number one, extract electrons by thermionic emission and accelerate them using electric potential. Number two, produced beam of high energy electron is bombarded on a metal target. This decelerates electrons and X-ray photons are produced depending on metal. Now, this is a theory. This is all that you need to know how X-rays are produced. For example, if somebody asks you how X-rays are produced, and this is a very straightforward question and very commonly seen in exams, your answer should be that X-rays are produced by decelerating electrons when they are hit into the metal target. All their kinetic energy is released in the form of X-ray photons. But if that is if question is only for 2 marks, but what if the question is for 3 marks? In that case, you can say that electrons are extracted from a metal using thermionic emission. Thermionic emission means we excite electrons. We heat up a piece of metal, so it is its electrons become very energetic, very excited, and they just eager to get out of the metal surface. So we excite electrons using heat, and then we liberate them from the metal. This is called thermionic emission. And after the electrons are extracted, they can just move in a certain path. Like, for example, if electrons are just emitted, they can go radially outward from the source in any direction. So what we need is a potential difference so that we can make electrons go in one direction. Okay. How do we do that? Just one second. It is coming up on the next page. Now, here we go. Now, this is what we do. This is a very simple sketch. There, if you can see that there is this small circuit, which has an alternating current, which goes through the heated filament cathode. So what happens is when current goes into this one, it becomes hot. And when it becomes hot, electrons have high energy, high kinetic energy. Electrons are, in other terms, very excited. So this small circuit, I'm talking about this circuit. Okay, I hope you can see the blue lines over there. So this circuit is a very separate circuit, because this filament is going to be connected into a different circuit as well. So this circuit that I drew, it will be used to heat up the cathode only. Now, this is very high potential difference, and it is a direct current. So it will always be positive, and there will be negative electrons over here. So what do you think, what will happen to the electrons? Because they were excited and they have a motivation to go towards positive. So what happens is electrons, they start to accelerate towards anode. Okay. So electrons what? They accelerate towards anode. There is this metal target. When electrons hit this metal target, they just lose their kinetic energy and photons are produced. And those photons, they come out from here. So this is where the X-rays come out. This is the gate for X-rays. So this is embedded in the notes, all this theory. You can read it, and all the technical terms are used over here. Now, one thing. How can we find out the wavelength and frequency of the photon emitted? Remember, the frequency of the photon depends on the frequency of photon depends on, number one, it depends on kinetic energy of photon of electron, which depends on potential difference between cathode and anode. So E equals to HF equals to kinetic energy equals to, let me write it differently. Energy of photon equals to change of kinetic energy of electron. Change of kinetic energy equals to potential difference multiplied by charge on electron. So there is a sequence. Number one, energy of photon is energy change of electron. I hope that makes sense. Now, if we understand that, we need to know that the kinetic energy of electron, which electrons gain when they move from, look, when they're moving from the heated cathode towards cool down anode, they on the way they gain kinetic energy because they come out of the filament, thermionic emission filament with zero kinetic energy, but anode pulls them towards themselves, pulls them towards itself. So when electrons are pulled, they gain kinetic energy. the final kinetic energy, overall change of kinetic energy, it only depends on the potential difference between the cathode and anode. I'm talking about the very high potential difference DC that is on the top of the diagram. That will control what should be the kinetic energy of the electron. If we have a high potential difference, there will be more kinetic energy. If we have less potential difference, there will be less kinetic energy. Now, if there is a high kinetic energy,
Okay.
electrons are, yes,
Yes, sir, वो zoom out कर सकते हैं, please.
like this.
Yeah, I just want the thing on the bottom. Okay, thank you.
Now, when electrons reach the cathode, they lose their kinetic energy, and that kinetic energy which depends on potential difference and charge. And how did I come up with that? Do you remember that electric potential was defined as energy per unit charge? So that means energy equals to potential multiplied by charge. So in this case, potential equals to PD, and charge equals to elementary charge, because we're talking about electrons. So here's a chain of thought. E equals to HF equals to change of kinetic energy equals to half mv square equals to potential difference into charge. So you can have any part of this equation and solve it for any missing value. For example, you can put HF equals to VE, or HF equals to half mv square. For example, if we want to know that what was the velocity of the electron when a certain frequency was emitted. So we put the frequency in place of F. H is Planck constant equals to 1/2. We know the mass of electron, and we can use this equation to find out the value of V. So any part can be put equal to any other part.
So that VE represent potential difference.
Yes, in this case, capital V represent potential difference, and small v represents speed. Okay. In the document that I have sent you, this is already embedded in that document. I will recommend that you go through the whole document, okay, and read every part of it. Okay, we can make all these equations from here. Confusion? Any confusion till now?
So can we solve some of the equation using this equation?
We did. For like we've been using this equation a lot in finding. Oh, you mean the EV part? We haven't used EV part.
Yes, sir.
Oh, we will be doing some Excel questions, and this is something that very seldom comes into exam. But if it comes, we can do. Okay, just keep it in your inventory. The rest is just reading stuff. You should go through it. One more technical thing is this one. To make X-rays more sharp, we need to have a smaller anode. The bigger the anode is, the dumber or duller the image will be. Look, if we have a smaller anode, as in case of the left diagram, you can see there is a full shadow and there are very small portion of partial shadows. If we use a bigger anode, larger anode, so full shadow becomes smaller and partial shadows become large. So the edges will not be sharp. This will be more sharp edges, less sharp edges. So what we do is over here, look, this is the size of the window. So we can change the size of the window, or that will help us to change the sharpness of the X-ray image. Secondly, we can make the X-ray emitter go away from the target. If this thing is placed far away from the patient, then the radiations will almost reach the patient parallel to one another, so image will become more sharp. So either we can make the window smaller. See, the window has gates. Some gates can move up and down, some gates can move left and right, and this size can change. Size can change to control. Sharpness. Like sharp, what is meant by term sharpness? Sharpness means how clear the edges are. If edges will be dumb, edges, there will be double edges, triple edges, then image will not be considered as sharp. If there's just single edges, then you're talking about a sharper image. Okay. To control the sharpness, we can control the size of the gate, plus we can control the distance of the X-ray gun from the patient. If we increase the distance of X-ray gun from the patient, the radiations will reach the patient almost parallel to one another and in straight lines. So they will produce a sharper image. Or we can control the size of the gate as well. There are two controls for the control of sharpness. Now, one more thing is called contrast. Contrast means that how different is the white part of the X-rays from the dark part, black part. So if white is very white and black is very black, that will be very high contrast. If white has multiple shades and black has multiple shades and there are gray areas over there, that means that has low contrast. Okay, so contrast can be controlled by the hardness of X-ray beam. And to make X-ray beam harder, what we can do is the number of things that we can do. Number one is we can use higher potential difference. With higher potential difference, we'll be providing more energy. With more energy, there will be high frequency photons produced. So that will increase the hardness of the beam. Secondly is, the second option is that we put a filter on X-ray that will take away all the low energy X-rays from the beam. What is the advantage of doing that? Low beams are more likely to get absorbed into human body and produce damage. X-rays are not good for human body. They can cause cancer, they can cause mutation. So we want X-rays to go into the body and get out of the body. So what we do is we use We use X-rays with a filter. So filter is supposed to get all the low energy photons out of it. So we will have less damage with that X-ray. Okay. So your homework for today is that you have to go through this topic, this whole 2-page part, and we will resume from the same point tomorrow.
Okay, sir. Assalamu alaikum. Have a nice day.
Sir, could you just send this today's recording?
Okay, I will.
Okay, thank you.